Alright, let's get our hands dirty and dive into something truly fascinating, the secret life of a bullet. Or, to be more precise, a cartridge or a round. You see, the term bullet technically only refers to the projectile, the pointy bit at the end that actually flies through the air. But what we load into a firearm is a complete system, a marvel of engineering packed into a tiny self-contained package. It's an object designed to do one thing with incredible reliability: convert a chemical reaction into kinetic energy. The entire process, from raw materials to final assembly, is a symphony of precision manufacturing, where every single step is critical. Failure is most definitely an option here, and it's one we have to meticulously design against at every turn. So what are the key players in this little drama? There are four main components we need to understand. First, you have the casing. Think of it as the house that holds everything else together. It's usually made of brass, and is the part that gets ejected after firing. Tucked into the base of the casing is the primer, the spark plug of the whole operation. It's a tiny, impact-sensitive chemical compound. Inside the casing, filling up the space, is the propellant, which is usually a smokeless powder. This is the fuel. Finally, seated at the very top, is the bullet itself, the projectile. This is the part that does the traveling, and it's what we're trying to send downrange with accuracy. Each of these parts has a specific job, and they have to work together in perfect harmony in a fraction of a second. The casing must be strong enough to contain the immense pressure of the exploding propellant, but also flexible enough to expand and seal the chamber during firing, preventing hot gases from blowing back at the shooter. The primer needs to be sensitive enough to ignite from the strike of a firing pin, but stable enough not to go off if you accidentally drop a box of ammunition. The powder has to burn at a precisely controlled rate to push the bullet out of the barrel at the desired speed. It's not just a bang, it's a controlled, directed explosion. And what about the bullet itself? Well, that's where things get even more interesting. It's not just a lump of lead. Bullets are designed for specific purposes. Some are shaped for maximum aerodynamic efficiency for long-range shooting. Others are designed to expand upon impact, a process called mushrooming, to transfer more energy to the target. They can be made of a simple lead core, or they can have a copper or brass jacket over the lead to improve performance and reduce fouling in the barrel. The science behind projectile design is a deep, deep rabbit hole. And it all starts with shaping metal to fly true. This whole system is a beautiful example of form-following function. Let's start the build with the foundation of our round, the casing. This process almost always begins with a simple brass disc, which looks a bit like a small, blank coin. This disc is fed into a massive machine for a process called drawing. Through a series of powerful presses and dies, the flat disc is pushed, pulled, and stretched upwards, forming it into a deep cup. It's a bit like watching a potter pull a cylinder of clay on a wheel, but with thousands of pounds of force and at incredible speed. The casing is repeatedly heated and cooled, a process called annealing, to keep the brass from becoming brittle and cracking under the strain of being reshaped. Next up is the primer, the ignition source. This is where chemistry takes center stage. The primer begins as a tiny metal cup, even smaller than the casing's base. Inside this cup, a wet, impact-sensitive chemical slurry is carefully deposited. A common compound used is lead styphnate. A tiny piece of paper or foil is placed over the wet mixture, and a small grooved piece of metal called an anvil is pressed into the cup. The whole assembly is then dried with extreme care. This creates a tiny, self-contained explosive package. When the firing pin strikes the primer cup, it crushes the chemical compound against the anvil, causing it to detonate and shoot a jet of hot flame into the main powder charge. Now for the fuel, the propellant. Smokeless powder isn't like the black powder you see in old pirate movies. It's a high-energy chemical compound, often nitrocellulose-based, that is carefully manufactured to burn at a very specific and controlled rate. The raw ingredients are mixed into a dough-like substance, which is then extruded through dies to create long spaghetti-like strands. These strands are then cut into tiny flakes, granules, or cylinders. The exact shape and size of these grains are incredibly important. They determine the burn rate, which in turn dictates the pressure curve inside the barrel. A faster powder is needed for short-barreled handguns, while a slower-burning powder is used for long-barreled rifles. Finally, we have the projectile, the bullet itself. The most common method for making simple lead bullets involves a process called swagging. A piece of lead wire is cut to a precise length, providing the exact weight needed for the bullet. This lead slug is then forced into a die under immense pressure. The die shapes the lead into its final form, complete with the pointed nose, or ogive, and the flat base. For jacketed bullets, the process is more complex. A lead core is inserted into a copper cup, and both are then swagged together, forcing the copper jacket to form perfectly around the lead core. This process ensures the bullet has the strength and aerodynamic profile it needs for its flight. Now that we have all our beautifully crafted components, it's time for the final assembly. This is where the magic happens, and it happens fast. Automated machinery takes over, turning these 4 separate parts into a finished cartridge with incredible speed and precision. The first step is to seat the primer. The finished brass casings, which now have a small hole called a flash hole drilled into their base, are fed into the machine. One by one, a primer is pressed snugly into the pocket at the base of the casing. This has to be done with just the right amount of force. Too little, and it could fall out. Too much, and you could detonate it. With the primer in place, the casing moves to the next station, the powder charge. This is one of the most critical steps in the entire process. The machine dispenses a precise, pre-measured amount of smokeless powder into each casing. The amount of powder is a crucial safety factor. Too little powder can cause a squib load, where the bullet gets stuck in the barrel, a very dangerous situation. Too much powder, on the other hand, can create an overpressure event, potentially destroying the firearm and seriously injuring the shooter. Every single charge is measured with extreme accuracy, often with multiple checks to ensure consistency. The next step is to introduce the bullet to its new home. The projectile is placed on top of the powder-filled casing. A machine then pushes the bullet down into the neck of the casing to a very specific depth. This is called the seating depth. This depth is important because it affects the pressure that will build up inside the casing when the round is fired. Once the bullet is seated, the casing is often put through one final die. This process, called crimping, slightly squeezes the mouth of the casing around the bullet. This ensures the bullet is held securely in place and won't shift during handling or feeding into the firearm. And there you have it. In a blur of mechanical motion, a finished cartridge is born. The completed rounds are then passed through final quality control inspections. These can involve visual checks, laser measurements, and even weighing individual rounds to ensure everything is within spec. Any rounds that don't meet the strict standards are rejected. The approved cartridges are then polished to a shine, removing any lubricants or residue from the manufacturing process. Finally, they are packed into boxes, ready to be shipped out. From a pile of raw metal and chemicals, we now have a finished product, a testament to precision engineering. So, what have we built? We've created a small, self-contained unit of potential energy. It's a system that relies on every single part doing its job perfectly. Here's a fun fact. The pressure inside a rifle chamber when a cartridge is fired can exceed 60,000 pounds per square inch. That's more pressure than you'd find at the deepest part of the ocean. The casing has to contain that force for a millisecond, directing it all forward to push the bullet. It's an incredible feat of material science and engineering. The precision required is staggering. Even a tiny variation in casing wall thickness or powder charge can affect accuracy and safety. This brings us to the paramount importance of safety. When dealing with ammunition, the rules are non-negotiable. Always treat every firearm as if it were loaded. Never point a firearm at anything you are not willing to destroy. Keep your finger off the trigger until your sights are on the target. And be sure of your target and what is beyond it. These rules exist because this entire process is designed to launch a projectile at high velocity. The careful manufacturing process is the first line of defense in ensuring a firearm operates safely, but the ultimate responsibility always lies with the person handling it. The reason for this obsessive attention to detail during manufacturing is twofold: performance and safety. For a target shooter, consistency is key. If one round has slightly more powder than another, the bullet will have a different velocity and a different point of impact downrange. In a competition, that's the difference between a bullseye and a miss. Manufacturers go to incredible lengths, using advanced sensors and statistical process control to ensure that the millionth round they produce is virtually identical to the first. This reliability is what shooters depend on, whether they are on the range or in a high-stakes situation. In the end, making a bullet is a story of control. It's about taking volatile chemicals and powerful forces and controlling them with incredible precision to perform a specific task reliably, time and time again. From the careful alloying of the brass to the specific geometry of the powder grains, every step is a deliberate choice aimed at achieving a predictable outcome. The quality of the ammunition is the foundation upon which firearm safety and performance are built. It's a serious business, and understanding the build process from the ground up gives you a whole new level of respect for what happens every time you pull the trigger. It's not just a bang, it's a beautiful, violent, and perfectly controlled piece of science.